Special cases for factoring. Perfect square trinomials. We can always try expanding, for instance, a plus b in parentheses squared. Well, the fact that there's a square implies there's two of them. So it's sort of like saying a plus b times, in another set of parentheses, a plus b. As we distribute, a times a gives us a squared, a times b gives us ab, b times a gives us av, and b times b will give us b squared. Note, we can combine the a's and the v's, or av's, into one, right? And once again, let's realize that a squared and b squared are there, right? They're squared. So in the middle term, ab exists twice, so we can say 2ab together. So we have a squared plus 2ab plus b squared. So how about we try expanding? So let's try expanding x minus 7 quantity squared. But first let's copy our formula down at the top. So our formula, it goes from a plus b quantity squared, so a plus b in parentheses and squared it. And we can always revert back and forth into our expanded form. So factored form on the left side, expanded form on the right side. Expanded form is a squared plus 2 times a times b plus b squared. So if it's a perfect square, it'll look something like what we have here, whether it's in the factored form on the left side or the expanded form on the right side. So the first case scenario, let's realize x minus 7, parentheses in square then, is in the factored form. And we can always put a 1 before the x. Be aware of that. If no number exists before the x, you can put a 1, which makes it a little bit easier to visualize. And let's realize that I sort of separate them out of it, that way it's easier to visualize which number is which, or which term is what. So let's try expanding this. Once again, expanding this into two sets of parentheses first, just sort of like what we have in the left side there. So we would have an a plus b, and then in another set of parentheses, another a plus b. Notice our a value is 1x. Our v value, therefore, is negative 7. So 1x minus 7 times 1x minus 7 in the other parentheses, or set of parentheses, I should say. So when you distribute, you're going to end up with something like what we have there, right? A squared, and then in the middle term, plus 2ab, and then the last term, b squared. So that means the a value, 1x. If you multiply 1 times 1, that'll give you just 1. X times x, that'll give you x squared. So we have 1x. Let's worry about the middle term later, but first let's go for the v value. The negative 7 is the v value. So negative 7 times negative 7. Negative times a negative will technically become a positive. 7 times 7? Okay, there we go. Makes it easier to visualize now, right? So we're squaring them. Two side terms, or n terms. The 1x quantity squared and the negative 7 quantity squared. Notice in the middle, it's just a multiplication of 2 times your a times your b value. So our a value of 1x and b value of negative 7 in the middle. Okay. So as we simplify once again, 1x quantity squared, 1 times 1 is 1, x times x is x squared. And on the right side, negative 7 times negative 7, what is that? Did I hear 49? You got it. And do realize the middle term, 2 times 1 is 2, and 2 times negative 7, well, that becomes just negative 14. Positive times the negative, still negative. So negative 14x. Notice I kind of left them separated quite a bit. That way you can visualize, and hopefully makes it easier to see which term is which. But now let's combine them, or let's put them together, I should say. A little closer, because after all, it is one expression. So we have x squared minus 14x plus 49 is the expanded form of this. So there is our expanded form for this particular case. And that's what we're looking for, the expanded form. Let's realize the next equation or expression. We want to factor it, so it's x squared plus 6x plus 9. The question is it a perfect square trinomial, first of all? So x squared plus 6x plus 9, there we go, copied over here on the right side. And now let's try to expand this a little bit, or separate this a little bit, I should say, because it's already expanded technically. So just give it more space, that way we can visualize which term is which. So we have the x squared plus the 6x in the middle plus the 9 on the end. Okay, so there's our formulas. We have a squared. Does x squared look like a squared? Yeah, because we'll put a 1 in front of it, right? It'll be 1x squared, sort of like what we had on the other side. Be aware of this. This is kind of like going in the opposite direction from the problem we just currently did. Okay, so opposite direction. Instead of expanding, we're factoring, so reverse order. So the 9, what number squared gives you 9? 3, right? 3 times 3 gives us 9. So let's realize that our a squared is just like saying 1x in parentheses squared. Keep in mind, I don't really need a 1, but I figured it'd make it easier for you to visualize having a 1 there. So it's a 1x quantity squared. Our b value squared, that would be a 3. We can go 3 squared. 3 times 3 would give us a 9. So b value is 3. And terms in the middle, it's 2 times x, or 1x, times 3, agreed? So there we go, 2 times 1x times 3. There's our middle term, technically. It always has a 2 times the a and the v value that we just found, or noticed. Keep in mind, most of this I'm taking a bit to explain, but ideally it's a little bit faster once you get the practice. So it takes almost no time to factor once you get the practice. So in this case, notice the middle term once again. Does the middle term give me the initial amount, the 6x at the top? So 2 times 1 gives us 2. 2 times 3 gives us 6. So there are 6x, which is the same as what we started with. So in that case, that confirms that it's a perfect square trinomial. So in that case, that means we can factor into 2 sets of parentheses, where we now know the a and b values, so it makes it really easy. So meaning we put our 2 sets of parentheses, and our a value comes first. It's a 1x. So I'll just write in 1x. Keep in mind, I don't really need the 1, but for your visual purposes, there's a 1x. Plus 3 is the v value, agreed? And let's repeat this once again in the other set of parentheses. 1x plus v, or plus 3 in this case, which is the replacement for v. They're repeated. It shows up twice. 1x plus 3 shows up in 2 sets of parentheses, so we can say it's a 1x plus 3 quantity squared. It's our final answer.